How might we inspire students who aren't typically interested in science to see it as a viable option or a valuable tool in their daily lives? What if students were taught to actively practice science rather than passively absorbing information? What if students discovered that science is as creative a field as art? BioArt is the merging of art and science. It informs my approach to teaching, which is centered on connecting students with nature. Here I present the LivingBioLibrary, a sustainable, student-driven collection of physical and digital resources with the aim to highlight student innovation and research. Here is a visual overview of how the LivingBioLibrary is integrated within my advanced biology course curriculum. In this course, students embark on a bioart project where they design, develop, and create a piece of bioart that they showcase in a culminating open house event. Based on existing library samples, students are encouraged to innovate designs for the physical library and document their explorations in the digital collection. Students are given the freedom to choose from different paths, including biochromes, biomaterials, or bioelectronics. Here we will focus on biochromes and biomaterials. The first step is for students to choose their topic of interest. This is facilitated by the nature of the interactive display. Students can bring jars back to their workspace to investigate during the ideation phase. QR codes on the containers lead to a digital library where students can browse information on their chosen material or dye. Based on existing library samples, students are encouraged to innovate their own designs to contribute. First, let's look at some examples of students experimenting with biochromes. Experiments with biochromes include fungi-based dyes, plant-based dyes, and bacterial dyes. Now, let's look at some examples of students experimenting with biomaterials. Students culture bioleather and prepare mushroom paper. Other biomaterials include biocomposites. Students work with plant-based materials and mycomaterials. Lastly, biomaterials include bioplastics. Students create algae-based plastics, biosilicon, and bioyarn. All of these experiments contribute to the growth of the LivingBioLibrary. Students add their research, trial and errors, and procedures to the digital collection. Additionally, students provide samples of their innovations into the physical library, thus ensuring that the library's expansion will be driven by ongoing student input over the years.